Hey Science 8s, it's Manchak here with your video lesson for Concept D3. And today I am not doing a video thing because my other computer's busy dealing with other video stuff. So I thought I would record it this way. That way I can also show you a couple of examples that we're going to need to go through. So today is all about Concept D3, mechanical advantage, speed ratio, and efficiency. But before we get into that, just a reminder, you should have completed Concept D1, which had us exploring simple machines. And don't forget that you had an assignment I wanted you to do in that one, which was to explore around your house and find examples of simple machines around your house, and then submit that to me. Concept D2 should also have been completed, and that was with respect to complex machines. So if you've got those two done, you've done the practice quizzes and the summative quizzes for those, then you are now ready to move on to Concept D3, which has us looking at mechanical advantage and speed ratio and how that relates to efficiency. So as you can see up here on my screen, we're going to talk about what force is to start with. We'll talk about mechanical advantage and speed ratio. We'll compare the two to each other, and then we'll quickly talk about efficiency. Your textbook pages for this section are 279 through 286, so you can guess this is going to be hopefully a relatively quick video for us to get done. I've got a couple of video links for you. There may be more if I find anything in the next couple of days, and some formative work for you. Questions out of the textbook, of course, another worksheet, and I'll post the key for you on the Google Classroom, and then a practice quiz. Always remember to do the practice quiz before you, and wait for feedback before you go and jump into doing the summative quiz. So I guess without further ado, I'm going to bounce into Google Slides here, and we're going to do a little bit of some presentation on this. So we are trying to understand now, or develop an understanding of mechanical advantage and work, and try to see how that helps us to determine the efficiencies of machines. The big point that I want you guys to have right now is that we have just gone through a couple of concepts where we've talked nothing but machines, right? And we should know by now that a machine is a device that helps to make our lives easier in some way. It often allows us to move a heavier load with less input force than we would have to if we used no machine at all. We also learned that things like bicycles may allow us to may get us to put a little more force into what we're doing, but it sometimes makes it faster. We get a greater speed out of things that way. So I want you to keep that in mind, that a machine makes our lives easier in some way. Maybe it makes it easier by having us expend less energy to move an object, or maybe it makes our lives easier because it makes something fast, makes a task faster for us. Okay, so looking into this, these are the concepts that we're going to cover right now. So we're going to determine the mechanical advantage of mechanical devices. We'll determine the speed ratio, also of mechanical devices. We'll explain the value of mechanical advantage or speed ratio and what it actually means to us. We'll build and modify a mechanical system to provide different turning ratios between a driven and driving shaft. Normally I would do this. I don't know if I'm going to be able to do. I don't think I'll be able to do this because we're not in the classroom and we can't fiddle with gears, but that's something I normally would do. And then we'll compare theoretical and actual values of force ratios if we can. Again, that would sort of come out of a lab that we would do in the classroom, but we're not able to do that right now. And we're going to start to talk about the idea of efficiency, which is a big idea for us in science. So, as I said in the intro there, we've mentioned a few times in the unit so far, a machine's job is to make work easier, and this is done by increasing the amount of force you exert lifting an object. And I want to be clear with what I meant by that statement there. It multiplies the force that we can exert on an object to allow it to move. We exert less force, but the object has more force exerted onto it. So this section is going to have us exploring the numbers associated with this. Where do these numbers come from? Where how can we explain those numbers? All sorts of things like that. And then what do those numbers actually mean? So Let's talk about what mechanical advantage is. Machines, like levers, make it so that we can exert more force on an object. What that means is that the lever provides a mechanical advantage, right? We might only be able to exert, let's say, 1,000 newtons of force on an object, which is an awful lot, but let's say we could do that. But let's say that the object weighs 2,500 newtons. Well, if the object weighs 2,500 newtons, maybe it's a car, and I'm trying to lift it myself, but I can only exert 1,000 newtons of force, I'm not going to be able to move that car. But what if I had a machine, like a lever, that would allow me to exert 1,000 newtons of force, which is all I can exert, but at the same time allow that machine then the machine allows me to multiply that force, and my 1,000 newtons of force are multiplied into 3,000 newtons of force. That would move my car because my car has a weight of 2,500 newtons. That's what mechanical advantage is. So mechanical advantage is simply the amount by which a machine multiplies force. So without the lever, I can only exert 1,000 newtons of force. With the lever, I can still only exert 1,000 newtons of force, but the lever multiplies that force into 3,000 newtons. Okay, so what we need to understand to understand mechanical advantage is two forces here. Okay, and before we get into that, let's just try to understand what force is. Force is a push or a pull on an object, and the amount of push or pull that we put on an object is dependent on or is related to the force. Okay, and that force is measured in newtons, and this would be a good opportunity. And I'm just going to tab out of this for a second. This would be a good opportunity for you to have a look at this video called "What Forces Are Acting on You," because it explains a little bit more about what those forces actually are. So the two forces we're going to pay attention to are input force and output force. The input force is applied to a machine by the operator, okay, and the output force is applied by the machine on the object. We could also call that object, right, the load, right? So let's not forget that we would call the object the load, right? So that's what we're talking about here. That looks like bad the way I put that there. Let's try that again. So the object is called the load, and I want you guys to think about that the object is the load. Okay, so that's the output force. So the machine puts an output force based on the input force that we put in. Both input and output force are measured in newtons. Okay, and our representation of newtons, by the way, we can just put a capital N to represent newtons. Okay, the greater the machine's mechanical advantage, the easier it makes the job to do. If you've got your notes in front of you, maybe do what I'm doing and put a big circle around that, because that is super uber awesomely important. We need to know that the whole purpose of a high mechanical advantage is it makes the job easier to do. Okay, so I'm going to move to the next. All right, so I had some technical difficulties there, but I fixed them now and we are good to go. So what I said on the last slide here, if you recall, was that the greater the machine's mechanical advantage, the easier it makes the job to do. What I'm going to do now is we're going to figure out how we can actually calculate what mechanical advantage is. So in order to calculate mechanical advantage, all you need are three things. You need the input and output forces, so there's two things right there, and you need this formula right here. Okay, this formula, mechanical advantage, equals output force over input force. So mechanical advantage is just a ratio. Remember, this is a ratio. This is output force to input force. What is the ratio of output force to input force? Now, some people like calculations, so I just want you to remember then that this operation here, this over that, is the operation of dividing. Okay, and we can simplify this into MA, pardon my horrible chicken scratch, is, and we can simplify it down into force of output, okay, our output force, okay, and that should be a subscript there, and then F, and then input, okay. So that is our calculation for mechanical advantage. Okay, so remember, output over input is what we're doing. Force, remember please, is measured in newtons, okay, which is capital N, and mechanical advantage doesn't actually end up having units. Remember, we're dealing with just a ratio here, and ratios don't have units. Now the last bit is right at the bottom there. The more the machine multiplies the force, the greater its mechanical advantage. And so we're going to find that the big mechanical advantages that we have on objects are a result of the multiplication of force that that machine does on the object. So what we're going to do now is we're going to get into some calculations associated with this concept. And I'm going to show you how to calculate mechanical advantage. And I'm going to do this in a way I haven't done with you guys yet. So I'm going to drag a window in here. Over onto my screen, and you're going to see that this is live, okay, and I'm going to actually do this calculation with you to show you how I'd like you to do it. Okay, so we have our first question here that says a pulley system requires 45 newtons of input force to move a load with a weight of 180 newtons. Calculate the mechanical advantage of this machine. Now, when I do calculations, I like to get myself organized, and normally in class we would have taken some time to sort this out, and we talk a little bit more about this. But what I like to do is I like to get some clues from the question. Don't just go for the numbers, right? Go with what's associated with the numbers as well. 45 newtons, but what comes after that? Of input force, okay? So that must mean our force input, our input force, okay, is 45 newtons, okay? And then it says to move a load. Okay, well the load is always associated with output force. Okay, so if this is associated with output force, then this 180 newtons has to do with our output force. So our force, output force, right? 180 newtons. All right, so what we do now is we have to figure out what's the ratio. Mechanical advantage is this ratio. How much is this machine, a pulley system, multiplying our advantage here? How much is it multiplying our force? So we know that mechanical advantage is our output force divided by our input force. Okay? And in order to calculate that, we are going to take, here is our output, so that's going to go on top. Here is our input, that's going to go on the bottom. So it'll be 180 newtons over 45 newtons. Remember, if you have something over something, it's going to cancel out. And so we're going to have no units left. Then you're going to bring your calculator in, okay? And I'll just place it up here, and hopefully you can see that. And we're going to do 180 divided by 45. Okay, so that gives me 4. And that's our final answer right there. So what this is saying, this mechanical advantage that we have here, is that the pulley system that we're using is multiplying the force that we are applying by 4. So if we apply 45 newtons, it's going to multiply by the force by 4 and bring us up to 180 newtons. So if I'm only able to exert 45 newtons of force and I have to lift a weight of 180 newtons, I can do it using this pulley because it multiplies my effort by 4. Okay, I hope that makes sense to you and how that works. Okay, so now we've worked through that first example. Let's jump into calculating the next bit here. So we're going to move into talking now about speed ratio. Okay, speed ratio is linked to mechanical advantage, but I kind of like thinking about it as a bit of an opposite sort of thing. If your mechanical advantage is high, then your speed ratio tends to be low. So calculating speed ratio is another way of analyzing how machines work. And remember that we're using the word speed here. So this is sort of the opposite. There's a bit of a trade-off when it comes to machines. Machines will amplify, sometimes will amplify your input or multiply your input, giving you a mechanical advantage. But if they're not going to do that, what they might also do is you may put more effort in, but it's going to make things happen faster. So that's where this speed bit comes in. So remember, speed measures the distance an object travels in a given amount of time. The more distance that an object travels in that given time, the greater its speed is going to be. The less distance it travels in a given time, the slower its speed is going to be. And it's a pretty logical thing to think about. So the measure of how the speed of an object is affected by a machine is called its speed ratio. And we can calculate speed ratio by using a very similar formula to what we looked at in mechanical advantage. But I will note for you guys that input and output are reversed here. Okay, and now we're talking about distance. Remember, speed has to do with distance. So your input distance over your output distance, or d input over d output, will give you speed ratio. And remember that we're going to keep things simple and just measure distance in meters in this case. So let's have a look at how we do speed ratio. And I'm going to drag that screen back over here and we'll have another look at this example. So a pulley system lifts a load 5 meters when 2 people pull the rope a distance of 10 meters. Calculate the speed ratio of this pulley system. So it's already telling us we're going to calculate speed ratio. We know speed ratio is your input distance. That's a horribly drawn P. Sorry for that. And then your output distance. Okay. How do we figure out which is which? Well, let's go back to the question up here. A pulley system lifts a load. Remember, load, we always said, has to do with output. Okay, so must be our output distance is 5 meters. Okay, and then when 2 people pull the rope a distance of 10 meters. Well, if people are pulling the rope, they're using the machine. So they must be putting effort in. So effort is always associated with input. So this 10 meters that's here must be our input distance of 10 meters. Okay, so then when we look at this, meters go up here, the input goes on top, the distance or the output goes on the bottom, and so we end up with 10 meters over 5 meters. My meters are going to cancel out. Again, speed ratio, just like mechanical advantage, does not have a unit to it. And our speed ratio is 2. And so what that means is we are amplifying the speed at which something is happening. So it's going to happen a little faster than it did before. So this speed ratio of 2, what it basically means is that the output, so our load is going to have to, our input is going to have to move 2 times further than our output. Okay, so what this means then is those people who are inputting the force on that pulley. So we've got a pulley system here, and we've got a load attached to it, and we've got some very poorly drawn people holding onto that load and pulling on it. What's going to happen is they're applying a force, and this input force, this rope, is going to move 2 times further than the load itself is going to move. That's what a speed ratio of 2 means. If a speed ratio was 4, it means that this is going to move 4 times further than this is. So we've got a bit of a trade-off going on here in this, and so I'm going to hit pause. So with that multiplication of speed, I wanted to get into talking about this idea of less force but greater distance, because in every situation we've got a bit of a trade-off going on. Okay, in this case we don't get something for nothing when using a machine. The advantage to gaining force is offset by the disadvantage of losing distance. So that pulley system has a mechanical advantage to it. right? It's going to make it easier for us to lift that load. It's going to multiply the force that we exert to allow us to lift that big heavy load. However, the trade-off to that is that we have to move that object over a much greater distance, or in other words, we have to pull that pulley a lot further than for each meter that we want to get out of it. We have to pull that pulley a lot further, at least 2 meters for every meter that we want to move it. So here's another way to look at this. An inclined plane makes it possible to lift heavy objects using a smaller force. So imagine that we need to get this very heavy box over here up onto a platform that's over here. And we're not strong enough to take it from here, lift it up, and plop it down on top. So we could use an inclined plane. If we were just to try to lift it from here to here, it would only have to move 2 meters. Okay. However, what happens here is if we used an inclined plane, it's got to move a distance of 12 meters to get up to the top. We have enough force to push it up here, but we have to push it over a much greater distance to get it to where we want it to go. So that's the trade-off. Gaining force through a mechanical advantage means losing distance. Okay, but if we lose force, as in the situation with a bike, by putting more effort in, what we gain then is distance. And that's what a bike does, is it has, and we'll get to this right now, it has a mechanical advantage of less than 1. So what that means is it's actually causing us to put more effort in than it would to just walk. But what the advantage, the trade-off of that is that we move much more quickly. So in the case of machines where mechanical advantage is greater than 1, the machine is multiplying the input force to get a larger output force. However, if a machine has a mechanical advantage of less than 1, it's useful for tasks that don't require a lot of output force. A bicycle is a great advantage of that. It's a machine with a mechanical advantage of less than 1. So what I said is we would put more effort into pedaling the pedals on a bike than we would on walking, but we would get a much greater speed from that bike, and it would get us to from point A to point B much faster than walking would. So it's still making our lives easier. It's just not imposing a strong mechanical advantage. So even though it has a mechanical advantage of less than 1, the output force causes the bicycle to move faster than the rider could walk. So it is still a very useful machine. So I wanted to compare real mechanical advantage and speed ratio to friction, and need to talk about this because it's something that's always there, but in order to simplify things, we often ignore friction just to make our lives a little easier when it comes to explaining. So when people calculate mechanical advantage and speed ratio, they may find that they are the same. In real situations, however, when they're calculated, they can be very different. This is because of friction. Friction is a force that opposes motion. The best way to think about friction is to think about the fact that if you let's say you have a little toy car and you push that toy car with all of your effort, if based on the basic physics that we've explained so far, an object in motion will remain in motion. But what happens is that object slows down eventually and comes to a stop. And that's because of friction. Friction between air and that little toy car. Friction between the toy car's wheels and the ground. All of that acts to slow it down. So therefore, the difference between the calculated value and the real value of mechanical advantage or speed ratio is the friction in between. So what we're trying to say here is I may, on paper, calculate the mechanical advantage of, let's say, a set of gears that I've created, and it might say I would get a mechanical advantage of 8. And then I go out and I actually test that machine. I actually use those gears and realize that no, it only gives me a mechanical advantage of 7.5 in real life. Well, the difference between 8 that I calculated and 7.5 that I actually got is friction. Okay, friction is caused, like I said, by the roughness of materials or by objects like air hitting the machine that I'm using. And it's because friction is a force in any device, additional force must be applied to overcome the force of friction. So the mechanical advantage of a device in real life will actually be less because our calculations that we are doing don't take into account friction. So I hope that makes sense to you. And friction is going to come up a lot as we move forward in different science classes. Speed ratio is not going to be affected. In fact, speed ratio represents the ideal mechanical advantage of a machine as if friction doesn't exist. Friction in a system also causes heat, which will cause additional concerns, particularly in engines and things like that. So the last thing we have to talk about on this concept is efficiency. Okay, and efficiency is a measure of how well a machine or device uses energy. Basically, the more energy that is lost, the less efficient a machine is. So you want efficiency to be as high as possible to make the machine as effective as possible. The lower the efficiency means more energy that we're wasting. And so one way, and I'm going to emphasize this, one way we can calculate efficiency is this. We're going to see next year in Science 10, when we take efficiency again, we're going to have another way to talk about it. Okay, but efficiency is represented in a percent, and it's calculated using the following formula when we're talking about mechanical advantage and speed ratio. And it's simply mechanical advantage divided by speed ratio times 100. Remember, that is just going to take our ratio here that is going to come up as a decimal, and then multiplying it by 100 is going to turn it into a percent. Okay, so this will take our decimal that we calculate here, multiply it by 100 to make a percent. In complex machines, there's many subsystems that are affected by friction and other factors. Because of this, most complex machines are not terribly efficient, but some are getting pretty good. In fact, I bought a furnace last year that's 98% efficient. And what they're talking about there is how good it is at converting the energy that is created by burning the fuel or the natural gas in my furnace and converting that into heat energy that we spread around the house. No machine can be 100% efficient, and I'm going to get out my marker again here. And oops, I'm going to go back here, and oh, it doesn't want to activate. There we go. And I'm going to circle that again. No machine can be 100% efficient. Okay, so if somebody, tracks you down online in one of those, not so respectful emails and says, "Hey, I got this thing that I want you to invest in, and I've created a 100% efficient machine," delete that email and move on, because that person is lying to you. Nothing can be 100% efficient. We want to get as close to it as we can, but it is not possible for something to be 100% efficient. There's always friction or gravity or something around that resists motion. Okay, so that is it for this concept and the stuff that you guys need to know. So I'm just going to bounce back to this screen here and just remind you that you've got some formative work you can work on. There's the questions on page 286, and then there will be a worksheet on in the Google Classroom under Unit D, Resources, Notes, and Worksheets. And you can have a look at that worksheet, do it, and then check it against the key, and you guys can do that first, and then when you're done that, move on to the practice quiz in the Google Classroom. Make sure you do the practice quiz first, then wait for feedback. Then, once I've said you're okay to do so, go ahead and do the summative quiz. So that's it for Concept D3. Sorry you didn't get to see me today, but I wanted to show you the calculations, and that was the easiest way to do it. I hope that you're staying healthy and staying indoors, or at least, staying away from other people. We'll get through this whole thing sooner by doing that. So as always, stay healthy, and we'll talk again real soon.